The quadratic formula gave us a method for solving quadratic equations, which works. Sometimes we have to modify the equation or drop in some placeholder values, but it also gives us a lot of opportunities to make mistakes. There's a lot of arithmetic steps in there. And again, for me personally, maybe for you, it's easy to make those small arithmetic mistakes. What we want to look at then is an alternative method for solving these types of equations using factoring, which, depending on how comfortable you are with factoring, can be a faster method. For instance, in example 6, we have x squared minus x minus 2. That would factor as x plus 1 times x minus 2, still set equal to 0. And then to solve from here, we know that this equation will be equal to 0 if either x plus 1 is equal to 0 or x minus 2 is equal to 0, because then we'll be multiplying the other factor by 0, which will send that side of the equation to 0. What that means is we can set up two separate equations. X plus 1 is equal to 0 and x minus 2 is equal to 0. And these are very simple to solve. We just subtract 1 to the other side, add 2 to the other side, and we have our two solutions. Again, it depends on how comfortable you are with factoring, but this is exactly the same equation we solved in example 1, but much more quickly if we're comfortable with factoring and we can jump to that factored form or arrive at that factored form relatively quickly. In example 7, which is the same problem we had in example 2, we could factor this as 4x minus 5 times 2x minus 3. And then we again have two equations to solve. 4x minus 5 is equal to 0, and 2x minus 3 is equal to 0. To solve here, we'd add 5 and then divide by 4 to get x is equal to 5/4, and x is equal to 3/2 as our two solutions. In example 8, we would want to take the first step here. Anytime we're factoring, always look to see if there's a greatest common factor. Here we can pull out a factor of 2, which simplifies the remaining part of this equation to 3x squared plus x minus 10 is equal to 0. That remaining quadratic can be factored as 3x minus 5 times x plus 2 is equal to 0. And now we'll apply the same approach. We'll look at each factor, but now we have a third factor, this value of 2. So we'll set 2 equal to 0, 3x minus 5 equal to 0, and x plus 2 equals to 0, and solve each of those expressions. The first one, 2 equals 0, can just never be true, so we don't get a solution from that factor. For 3x minus 5, we would get x equals 5/3 as a solution, and for the last one, we would get x equals -2 as a solution. In example 9, we have to take the step that we looked at with the previous problems with the quadratic formula and update this to get our quadratic equation in standard form. Moving both terms to the left-hand side of the equation lets us do that. And then we have a quadratic equation that we can factor as x minus 1 times x minus 5 is equal to 0. Set each factor equal to 0 and solve those two simple equations, giving us x equals 1 and x equals 5 as solutions. When we looked at the equation that we have in example 10 using the quadratic formula, we'd have to introduce the missing term for that constant. We'd have to introduce a plus 0 to know that our value for c is 0. But if we're doing this using factoring, we can start off by identifying the greatest common factor, which would be x in this case. leaving us with x times 2x plus 5 is equal to 0. Now we have two factors. X is equal to 0 and 2x plus 5 is equal to 0, which we can solve. X equals 0 is already solved. That's one of our solutions. And then our other solution would be x equals negative 5 halves. Again, it really comes down to how comfortable you are with factoring. You can always rely on the quadratic formula, but again, I think that introduces a lot of opportunities to make small mistakes. So I would recommend looking into the method using factoring and see how that works out for you.